On September 29, 1513, Vasco Núñez de Balboa climbed to the top of a ridge on the Isthmus of Panama and became the first man from the Old World to set eyes on the Pacific Ocean. Now, 5 centuries later, another ocean has been discovered. This one far larger and deeper than the Pacific. It is located on another world 500 million miles from Earth. Jupiter's moon, Europa, is about the same size as our moon. But since it is 5 times farther from the sun, it is a frozen world, or at least seemingly so. In 1978, Voyager spacecraft flybys of the moon discovered a bright, very flat surface composed mainly of ice. Little evidence of impact craters meant the surface had been geologically active enough to erase the effects of constant bombardment from comets and asteroids that were attracted by Jupiter, but strike Europa instead. More intense study of this world by the Galileo spacecraft revealed that this moon's icy surface hides a great secret. Scientists are now in general agreement that about 10 miles below Europa's icy crust lies a vast ocean about 60 miles deep. It is a salty ocean with about twice as much water as all the oceans of the Earth. This conclusion comes from several observations. First, impact craters are very rare, and the few that are seen are shallow, as if their deep floors were filled in or flooded. Second, the surface is crisscrossed with long ridges that are broken up by chaotic terrain. The broken pieces of crust can be shifted and rotated back to original positions that indicate they periodically break free and float to new positions. In fact, some areas on Europa look like icebergs breaking off continental ice sheets on Earth. Finally, as Europa moves through Jupiter's changing magnetic field, an opposite field is generated due to the presence of an electrical conductor near the surface. Salt water is the most likely agent. The process that keeps Europa's ocean from freezing is tidal heating. Europa's 3.5-day path around Jupiter rocks it back and forth because other large moons pull Europa slightly away from a circular orbit. This is just enough to stretch and then compress the moon every orbit. Heat is generated by this deformation and probably creates volcanism under the ice that keeps the ocean liquid. It probably has undersea volcanoes, similar to what we found on Earth's mid-ocean ridges. On Earth, these deep and forever dark vents host unique life forms that live off the chemical energy of the eruptions instead of sunlight. Could a similar habitat exist in the alien ocean of Europa? The combination of liquid water, a volcanic energy source that has probably been active for billions of years, and sources of organic materials that break into the ocean when comets strike the surface make Europa a prime target for future searches for life. Who knows? Maybe a child today will grow up to pilot a robotic submarine to search for life in an alien ocean.